Hello, it's Dennis. And some of you have seen me on stream yesterday with Adrian. And today we're back solo for a shorter session today because it has been quite a busy week and we are experimenting a lot with the streaming format. Today's topic, temporal coupling. So we had a lot of discussions lately and with the teams that I coach and also other trainers, other coaches regarding time and how difficult time as a concept can be. So today we're discussing let's say, the more productivity affecting details of time and how to think about them, um, how to approach it, and sort of inspire you. Perhaps there's a part of time that you're not managing. Perhaps there's a time part of time that you're not modeling. Perhaps there's a part of time that you're not focusing on. And today's, let's say, win would be to inspire you to think about time slightly differently. So if you're here in chat, let me know. As always, we will primarily swim the chaos of your questions and happily explore wherever you want to take this. You are actually much more in control of these streams as you would like to think. So I really appreciate and really value your presence here, that you decided to take the time to show up live, ask questions, and I'm aware that in the first few minutes, people are still trickling in, dealing with the YouTube ad blockers and whatnot to really try to get comfy and sit down and get situated, get that glass of bottle, get the coffee, get the beer, get the wine, or just in general, get your juice or healthy smoothie or ginger shot because I'm a bit under the weather. And let's get started. So the topics for today are touching on, let's say, the top level aspects of time. How can we work with time? How does time affect us as software engineers, as a tech organization, as teams, remote teams, on-site teams, right? So local or remote teams. How does, is this going to be a talk about asynchronicity and synchronicity? Is this going to be about temporal dependence, not just coupling? So we're going to go dig a little bit deeper into those terms because I'm aware that I just mentioned a bunch of terms that might not make sense to you. So we'll start with sort of looking into what this is, why this matters. Oh, and I'm autofocusing a bit weirdly. I'm very sorry. It's probably, there we go. And so number 2 is time autonomy enables modularity. That's how I named sort of second part of our talk today, because it's usually what I see as a coach sort of downstream, what teams struggle with. I sort of zoom out a bit and I see that, this struggle is caused by this coupling. And if I do that step one more time, I often notice that this kind of coupling is usually temporal in nature. And number 3 is the inverse of that, time independence, either loosely coupled or decoupled, but generally time independence is, I think, a term that we can sort of use today to talk about decoupling or loosely coupling, sort of the looser end of the spectrum of coupling, and how that helps you sort of move faster, and how that really then makes sense in the context of microservices or more modern technologies or modular monolith. So I want to just briefly touch upon connaissance, because connaissance is, we can look at it as, what is time per se? Why does time affect us? Right, so time affects us because we generally have 3 patterns in our day-to-day data flow. It's about data primarily, right? So imagine you have an invoice. The invoice, there are 2 types of, let's say, categories of work that we want to do today. There is, let's say, a subscription, an invoice, and actual payment. Okay. Now, I'm gonna keep using just this example for today's context, just to make it really, really simple. So, what does time mean here? If I have a date on an invoice, generally that means that it was paid on that date. Now that's already an assumption. Now, if I have a date on a subscription, that might already mean a lot of things. Right? So a subscription might have a date of when I subscribed. The subscription might be a date of when will the next payment be? When will the next payment cycle be? When was the last payment attempt that was unsuccessful? When will the retry happen? Right? So the subscription is already extremely complex in time. And when I was starting off as an engineer, sort of into my sort of mid-level to senior journey, I was actually building, just before Stripe came to market, I was building a subscription service in a startup that was e-commerce focused, and that was a nightmare because it was much more complex than I thought. And I thought to myself, where is all this complexity coming from? And then there's the third element to the actual transaction, is that the transaction is atomic. The transaction is usually a state of this has already happened. And now you can probably see the problems of bitemporality, as Kent Beck likes to call them, especially if you read his new book, Tidy First, and his Substack. I can wholeheartedly recommend it. Oh, wait, we're not. There we go. And in Tidy First, especially, he mentions, and in his newsletter, he mentions this idea of bitemporality. Bitemporality really captures the degrees of freedom that you might want to say, I will only talk about time-based problems from a context of facts, for example, right? So me knowing that the next billing cycle for the subscription is on Tuesday, that's a fact. Now, if I say I'm going to create an invoice for that day right now and put the date into the future, that's not a fact. That's some kind of draft. That's some kind of speculation, right? So this is already a sign that somebody is messing a bit with temporal coupling in a sort of badly modeled or a lazily modeled way. That seems to be like the easiest choice, but it doesn't bode well as this invoice, if you put the date into the future, as this invoice travels through time, it creates a whole bunch of problems because of its coupling to the temporal effect. Jose, hello. Camila, it's great to see you. So Camila was hosting, actually, moderating yesterday's conversation with Adrian. So Camila is Adrian's coworker, employee, and it's great to see you all. So you have a more front-end focus, from what I understand, Camila. What temporal coupling problems have you run into, or can you spot them? Like that would be my sort of focus for today. Can you spot them? Jose, hello. Oh, I didn't do what I usually do, which is keep a second window open for my backup chat. Let me do that real quick. Sorry. Production. Okay. Chat. All right, now we're ready. Okay, so Adrian, hello. You see Adrian's message I can't see coming through. Jose, Camila, it's great to see you. There we go. Okay, now everybody's here. So regarding temporal coupling, what you really want to be focusing on is to spot it. You want to find a piece of technology, a microservice, or a model, or just a function. Anjana, hello, it's good to see you. So one of those modules, one of those components that is speculating, right? So when I say you need to pay me tomorrow, that's speculation. Now that might be a fact. It might be a fact that today I think you need to pay me tomorrow. But if you don't pay me tomorrow, and today I projected a date onto tomorrow, then once the real time is past that point, it stops being a fact. And it actually becomes a fact, which, if you look at it backwards, becomes a fact of falsehood. So it is true that this was the case then, and it didn't happen. And this is one of the hardest parts about temporal coupling. And you see this a lot in accounting, where ironically, accounting and team management, which is point number 2 and point number 3 basically for today's topic, which is if I promise something, let's say an estimate, or going back to our subscription model. Let's say I promise that I will charge you on Tuesday, and then we go blah 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 blah, blah and then it's Wednesday, and on Tuesday we didn't charge. Now that object, that data class, that whatever it was, that service said, well, I should have charged you on Tuesday. What happened? Because now you need to think about it this way. Now, when I'm charging it backwards, and let's say that another month passes, now there should have been 2 charges. But it's possible that the charge is charging you for a subscription service, let's say for active usage. Now my question would be, if now it's November, and in December you have to pay November, you have to pay December, and in January you figure out you didn't pay. If you ended up not using it anymore and you block your credit card and have all these uncaptured subscriptions, if you didn't use the service, should I charge you for November? Right, so it opens up this temporal coupling problem of my objects are modeled in such a way if the happy path is followed correctly through time, but only in one direction. I'm not allowed to change it. And you see this often in Git, for example, when you rebase something. There's usually something weird happening when you interactively rebase and you have a conflict. And you naturally want to presume that you can just move to the end and resolve the conflict once, but because you're rebasing, you have to rebase everything that is causing a conflict by moving time backwards and then replaying it back forwards. This moving time backwards and replaying it forwards is actually a property of event sourcing. And you often see this in like things like rebasing in event and in Git and subscription models with payment systems, and there are other case scenarios where the model, the business, especially if it's complex, it is only modeled and defined to behave correctly if it is moving through time forward, right? So it is not a bijective. It is not a bijective, transitive, and symmetric operation. So you cannot undo, right? There is no undo operation for me sending an email. There is no undo operation. If I charge your credit card and it's not a debit card, it's very possible that I cannot send you money to that account, right? So there are even types of bank transactions that cannot be undone. They have to go in a loop where I need to ask you for some other account where I wire the money back, or I give you something else in return if that's a too complex operation, right? So there are a whole bunch of business processes that are irreversible. And business processes, and usually we call them side effects, business processes that are irreversible have this temporal coupling problem of you need to get it right. And if you don't get it right, you can't undo it. You need to correct it. So you need to write another thing to correct it. This is a typical problem in accounting. You make a mistake. Well, if everything was by the books and the mistake was now acted upon, maybe we made a mistake and we paid taxes on it. Well, now we need to correct it. But it's possible that correcting it backwards actually comes with a penalty, or correcting it backwards might comes with other side effects, where maybe because we did pay too much, we passed some limit, but now then we figured out that we paid too much, and if we hadn't paid, wouldn't have passed the limit. And there are all these open questions that come up when you're messing with time, because you cannot undo it. Time flows forward. Your models give this illusion that you control everything, and temporal coupling is, let's say, very bad or very destructive in your effort to shape your software when you are making assumptions of how powerful of a control you have over time. Oh, yeah, I can just play it back in this way and that way, and it will always work. That's not always the case. One of the stronger problems that I encounter a lot with teams that are struggling with this concept is idempotence, where you say, well, I want to send a message and I only want it processed once. So if I send it twice, don't process it twice. Unless I double click, but then I need to know, did I send it twice or was it a double click? If I did send it twice because I clicked twice, was that intentional? Right, so there are already this, how do you know it's sent twice? Oh, because it's very close together. Again, that creates a temporal coupling problem. It's like this model, this problem exists if the two events are close together, but if they're not close together, then it was a human interacting with the system twice. So you might have to rethink how you're thinking about, let's say, how you think about small cadences in time and large cadences in time. So that's number one. So the how to spot it, you want to spot when you are modeling passage through time based on assumptions, based on some final state, without actually taking seriously that it moves forward. When you have no undo operations or you don't know how to correct them, or when you have certain operations that are time sensitive in the context of if two things happen simultaneously, then it's really important in what order they happen. And in the terms of connaissance, these are connaissances of timing and execution. So those are, let's say, the most destructive types of connaissances. We covered connaissances in a previous talk. I'm just gonna put it on connaissance. I'm getting really good at spelling it because it is a bit of a tongue twister. Connaissance, right? So this is the image I usually reference. It's from a blog called Khalil Stemner. So this is what I want to share with you. Let me know, by the way, if this is hitting some brain cells for you, if this is interesting, because we can jump straight to microservices if you're interested in that. So when it comes to teams, it's very important that you need to know if I have, so the dynamic part is really tough. When I'm building a module and has a lot of this high bad connaissance, this kind of coupling, timing, execution order, and then there's value and identity, right? So the combination of timing and identity would be, not only do we need to talk to the same instance of something, but we also need to talk in a correct order, and that is usually what a saga is. A saga is something that is coupled by identity and timing. That's why it's such a difficult concept, and most architects tell you to avoid it because it does not manage the complexity. It just gives it a name and says, okay, we're coupled this way, and we'll just put it in a saga. Because you could have a natural process to this flow that might not require coupling connaissance on the lower end, but you could actually solve it with something above the sort of yellow part of the spectrum. Yeah, let me see. Checking for comments. Okay. Hello, can you hear me? Does chat work? I think chat works for me. In the other window, StreamYard, it is what it is. Let me know if you have any questions regarding connaissance, timing, and temporal coupling. So we're now going to slightly jump into coupling between teams. So the reason you might ask, Dennis, why is this so important? How does this affect me? Well, if you work solo, it might not affect you too much. You might just have a complicated subsystem and you'll just tackle it however you decide because you'll have everything in your brain. But how it can affect you negatively is that you can be affected by your module being coupled to another team who owns another module where that is coupled by time. Time in this case could be anything. That we deploy at the same time, that we have the same version up at the same time, that we have the same uptime, that when I'm deploying a feature and I'm changing something and you're coupled by value to something that I'm serving to you, that you need to be synchronized with that. And this kind of coupling, for those of you who are front-end developers, this happens a lot with backend and frontend, right? When you say, I'm going to update my frontend, I need the backend to be updated. Can the backend be updated independently of the frontend? Can the frontend be updated independently of the backend? Can the backend serve the old and the new frontend at the same time? Can the frontend read from the old and new backend from at the same time? Right. So these are all this is all temporal coupling mixed in with a little bit of identity, because you're dealing with this idea of, well, I don't just want to have a snapshot of my finished system, but I also need to monitor and to model how the system evolves over time. Because one of the discrepancies that I see a lot with teams that are doing sort of more traditional types of diagramming, database driven, sort of feature functionality driven or screen driven project planning, is that they plan projects by taking a snapshot. Imagine there's a timeline of the project being built, and they plan the project in such a way that they imagine being at the end, and then they make a snapshot of the feature when it's done, it needs to look like this. The feature when it's done, it needs to look like this. The feature when it's done, it needs to look like this. The feature when it's done, it needs to look like this. This system when it's done, it needs to look like this. This feature when it is used and done and we move on to something else, it needs to look like this. So you're only looking at the system from a future point where it is already done, but you're not discussing how the system evolves over time. What is the first thing we're building and how does it evolve over time? Can it be linearly evolved and grown into that final state? This also happens with the same subscription, invoice, transaction model, right? And you can say, well, at the end of the year, I want 12 invoices for this user for a monthly subscription. But now how that flows over time is extremely important, because if you missed charges on them and then you suddenly realize that in December that you forgot to bill 11 invoices, well, billing 12 invoices backwards in a batch retroactively might be inappropriate, right? So you can't just fix the problem, right? So if I tell you, yeah, at the end of the year, it has to look like this, there have to be 12 invoices, you might have a unit test for that. But if we have figured this out too late and now we're actually creating the invoices today for the last 12 months, and God forbid, because then you batch them together and they just, so the invoice for March might be created before the invoice in June. Sorry, no, that's correct. The invoices for June might be created before the invoice in March, because they will all create simultaneously. So maybe the ordering process doesn't work very well if everything happens in the same millisecond, right? So there are all these little problems that start arising because a lot of these human processes are modeled based on the assumption that the human operator who triggers the commands is slow. So usually there's this discrepancy happening on, oh yeah, I don't need to think about this problem because the human is so slow that they can do only the one thing at a time. So it's not modeled. This kind of coupling is not modeled. Whereas then if you start automating for example, me doing a transaction from my account, if I do it manually, I can't do more than one because I need to type. And I can't type and hit enter on more than one transaction at a time. But if I'm using a service, it's very imaginable that I'm clicking something and the act of double clicking, because everything is automated, it does 2 transactions. So the human manual process never had this problem because it was assumed that the human will always be too slow to cause this, to do the problematic behavior by themselves. But if you automate it and I double hit enter, well, now we have a problem. Because now the automation itself made the frequency so small that we have new corner cases to think of. And then what to do with, okay, he paid twice. What should I do? Should I refund? Should I not refund? What's the grace period here? What's the strategy here? Did both of them go through? What if I decide to refund the one that went through and then the user also refunds one of them because his bank also flagged one of them? What happens then? What is it paid? Was it not paid? Was it paid twice? Can I refund an order twice if it was paid twice? And I assumed it was only going to be paid once, right? So this idea of an invoice can have 2 transactions, right? So if I have an invoice for 1,000 euros, I can pay 900, and then the next day I can pay 120 in dollars, and then that together will make 1,000 euros. But that's 2 different transactions in 2 different currencies. this can happen. But now this is a one-to-many problem and sort of n+1 kind of problem. But there is this temporality aspect of, if I told you once, I'm expecting it to happen once, not because I can't handle the money volume, but because when I receive payment, I will only validate it once, right? So there is a workflow problem. I am modeling the coupling of the workflow. When you pay, I will sort of open the gates and I allow you to do something. So when you pay and it's not enough, I don't know what to do with that because I don't know whether you'll pay the difference. So in e-commerce terms and sort of payment terms online, we've come to agree that whenever there's a payment to be done, it's assumed that it has to be done in one transaction because otherwise the whole temporal flow breaks apart. Camilla had a great question. Hang on, let me turn off the banner. So I can recognize them mostly if I'm making an assumption. There is no undo operations and side effects running in business operations that are linear. Business operations that are linear is actually a very good specific. What you might want to also be looking for is natural loops in the business behavior, right? So a recurring subscription is something that is a natural loop, because you might also think about it this way. If I tell you, you need to pay an invoice for January, you have a subscription, I'm subscribed to Spotify, Spotify sends me a bill. If they send that bill and they invoice me in January, and it takes some time to process that transaction, is it correctly being backlogged? Right? So you might, in January, you might check, hey, did Dennis pay? And the answer might be no. But Dennis received an invoice. So Dennis will intend to pay because there are payment terms to this. Right? So now there's another bitemporality problem, for example, is I produce an invoice, you have to pay it within 30 days, if it's not automated. So do I provide the service or not? If I know it's going to be paid and you have 30 days to pay it, I'm speculating. But what happens, should I open up the service once you pay? That means I need to be monitoring when you pay exactly and then bound it that way. But if you pay and you want to use it right now, do I allow you? I also have this Mentor Cruise, for example, has exactly this. It has recurring subscriptions. Sorry, I'm assuming most subscriptions are recurring. It's a subscriptions. It produces invoices. But mentees, when they subscribe to me on Mentor Cruise, they have a 1-week trial period. So there's this important question now. When should Mentor Cruise charge them? Right? So if they have a trial period and it's kind of for free, do we charge them at the beginning of the week, at the end of the week? What happens if they change their mind? What happens if because then Stripe also has this mechanism of creating a charge and capturing the charge. So you can create a charge where you check, will the credit card be able to be validated to capture this? And then you don't capture it. And then a week later you capture it. So on the credit card, there's already an intent of payment. So it sort of blocks it off, but doesn't capture it because it goes with the sort of MasterCard system of being able to defer the debit itself from the debit payment itself from the credit card. And these are all important concepts when it comes to temporal coupling. So Camilla, your case here is, yes, well, for side effects running in business operations that are linear, I would also say that when the business process in itself has a loop, and it is assumed to be an unhappy path if the loop repeats. For example, if I have a subscription for Spotify, it would be an unhappy path if I was charged twice for January, right? So it says, okay, did Dennis pay? No. Did we send an invoice? Yes. Okay, good. Now Dennis's credit card bounces on that invoice. Okay, not paid. It's still January. The check goes again. Did Dennis pay? No. Okay, send an invoice. Well, that's not okay. We already tried once. Aren't we just going to retry the previous invoice? Because now it will look like Dennis has 2 unpaid invoices, right? Because Dennis will then receive emails, and then he'll look at both emails, reading them backwards because they're in descending order in his inbox. So then what will Dennis be thinking? Are we double charging him? He might be right to complain that, hey, you tried to double charge me, so I blocked my card. Because looking backwards at the problem, that the temporality of it might make it look like there was some scam going on. But really, it was just some automation, not understanding, okay, what should happen when this doesn't happen? Should I turn it off? Should I turn it on? Is there a grace period? And usually it's this part, the unhappy path, sort of the non-trivial cases that are really complicating things when it comes to modeling time. Let's make a marker here. So how does this affect you? See, in order to retain your productivity, and I don't want to talk about this in the context of creating productivity out of thin air, but productivity for your team is, if I can deploy something independently, that means that I am not, the things that have a timeline on my service do not depend synchronously, or at least with some degree of feedback from another service. Which means that if I have to call another service, if I do that through a web call, either that call should be allowed to fail so that I can retry it later, or it should be done asynchronously through some message queue. But that means that if I have certain guarantees to make on my end, so if I have a subscription service, imagine now in this, again, subscription, invoice, transaction, I'm building subscriptions, and I'm talking to the invoice service, and when I'm charging the subscriptions, I'm telling the invoice service to create an invoice for all of the uninvoiced subscribers that are active in a sort of billing cycle. And the invoice service is down. It is not operational. It's not visible in the network. Maybe it's being redeployed. I don't know. So what should happen, right? And let's make matters worse. Let's say some of the requests went through, and then mid-processing, it went down. Now, if it's a REST call for each hop, then you might have a problem, because then you might have said, oh, I have something called a billing cycle, and I'll charge all customers. If you can't do that continuously with idempotency, then you have a problem if that process fails midway. Because it's possible that half of those customers have already charged, but then it crashed. And it crashed because I couldn't wrap up the saga or the transaction. But the system for the next loop, the next iteration, failed because user number 147 crashed, because at that point the service went down. It went dark, no longer responded. So you might have this coupling problem of I have a flow here. When I charge a subscription, I guarantee that the invoice exists. But to have that guarantee, I need to be coupled to it tightly to guarantee it in my own flow. Which means that if this is down, then the moment it goes down, my flow is also down. Now the problem is that if this is a monolith, there is no problem. Because they will be the same thing. They are the same identity. So if the invoice service is down, by virtue, the subscription service is also down. Now that's really good, because that means that they are always down or up at the same time, right? So that's what we're talking about. Identity versus temporal coupling versus timing. If it's the same thing, then it's always up. Then I will always have guaranteed that it will always be up in the same way. And if I have a huge big ball of mud monolith, then I can make more complex guarantees about time. And that's really what this session is about, is that the article that I'm writing about temporal coupling is that microservices, they don't really, they're not about size of service. Microservices, what they introduce, the problem that they solve is not the size of the service. What they solve is the timing of it. Microservices that are sort of decoupled through a message queue or some other asynchronous protocol that might be buffered or retried, what they allow you to do is to introduce a seam or a indirection in the messaging flow that allows you to decouple, to make it time independent. Where I say, okay, I have these subscriptions, I need invoices for them. Okay, then the invoice service will pick them up. It's like, oh, I have all these unprocessed things in the message queue. Okay, let's do that now. And then I'll let the subscription service know that now I'm done. And now for all of these that for which we have a handshake of subscription and invoice, we will then send an email. And then the email service can also be down, and then there's another indirection there, etc. Now, if that's done on a big ball of bud monolith, it's possible that it's guaranteed to work if the server is up, because nothing can crash because everything is tightly coupled, but it creates a time coupling, and this is where the second topic really comes in. It creates a time coupling to the team. And you've probably noticed, you probably know this, whenever you have a project that has downtime on the front end, downtime on the back end, cron jobs are notorious for this, where somebody on the team will say, oh, we can't deploy this on Friday at 4 p.m. Because that's when you do this important cron job. And you've probably been in a situation like this before. Or you might say, oh, this is when most of our users are using the system. We can't deploy right now. Okay, autofocus, please. Like, you're automatic and everything, but this is really what's going on. Is it because my forehead is shiny? Oh, there we go. Oh, no, it's because the light reflects on. It's white balance. Yeah, the white balance is off. I look pale. Am I pale? No, it's the lighting. Yeah, it's just the light. I have white screens open on my screen. That's the problem. That's the problem. Okay, let's do this. How's that? Okay. Okay. Whatever. So there's this element where you might say, because I've decided to separate something out into a microservice, I have dealt with, like, say, the size and the boundaries of a system. But it's also really important to think about, did I decouple it through time? Because when it was still together, I didn't have this choice. Or at least the choice was very clumsy. Now, you can still do it, and that's usually what's called a modular monolith, where you have a monolith and there's modules, and they don't assume the function calls to be temporally available, right? So when you have an object and it references another object and it calls a method, which, in object-oriented programming, calling a method on another object is called messaging. And that's how in Next, the first object-oriented language for the Apple one. No, is it Next? Smart Next? Next. I think it's called Next, right? Next. So lowercase E-N-E-X-T. Next, right? Yeah, I think that's what it's called. Next Step. And that was an operating system. So calling a function or a method and an object or a function, that's usually called passing a message, calling an object and passing a message. So the temporal coupling that comes with your natural programming language, maybe you're a C# developer, maybe you're a JavaScript, TypeScript developer, PHP developer, C#, Ruby, Go, whatever floats your boat. There must be somewhere here coding in Rust. Come on, please tell me somebody's coding in Rust in chat. Is that there is this implicit temporal coupling when you call a function, is that you assume that function is available in memory, that the code was loaded, that the object was loaded. Now, that is a very natural way of thinking about services. But when you start decoupling, one of the things that I did, one of my first strangling fig implementations, and I talked about this yesterday on Adrian's stream, where we discussed the strangling fig tactics in detail, was I sort of tried to do this SOAP thing, if you remember SOAP XML, where I tried to hide the fact that this is a different server. So I created what looked like an asynchronous library so that you could, in code, just call a function and it would appear as if it's synchronous, but it's actually going over the wire. And I was really convinced that was a good idea, right? Because I could then maintain temporal coupling. I said, oh, temporal coupling, that's nice to have. So even though I'm moving this to another server to get away from the legacy code, I want to keep that. And that was a huge mistake. Because while you maintain temporal coupling, you no longer guarantee that these two systems are up at the same time. While it's in the same server, the same code, the same two files, the same two source code files, they will live together, even die together, come up together, go offline together, and be online together. and they have an implicit coupling, and well, a guarantee, not really a coupling, a guarantee that they will be available at the same time. So not always available, but they will always be available exactly at the same time. Yes, yes, or no, no. There will never be a yes, no, or no, yes situation. And when you go to microservices and you keep the temporal coupling, because it makes your code cleaner on one side, you ignore the situation of now the reverse happening. Like it's like this one's up and this one isn't, or this one's up and this one isn't. And this can go both ways. You might have a request on the REST API and you can say service A calls service B. What happens if service B is offline? What happens to service A? Is that an error? Is that a data point? Is that a lack of data point? Will we retry? If we retry, can we accidentally send it twice? If we did, can we detect it? If we can detect it, but we can't undo it because it's a non-reversible linear process, as Camila mentioned, what are the side effects of that? How do we want to minimize the negative impact of that? That's one case, and that's the easy one. The hard one is when you say, A will call B and expects a response, and A goes down while B is sending the response. Now that scenario is a source of nasty bugs, because that's the really hard stuff to debug, where I call a function and I might observe both systems and I can see, yes, both systems databases are in sync and the logs look fine, but the response didn't make it back to my system. A lot of developers don't expect that can happen because they just assume that the temporality problem is exactly the same as it was in the monolith. Now, what you might want to do is to make this problem explicit by adding a message queue. And then engineers will exactly respond, architects even, to the same degree of problem. But then if I want to send a response, I need two queues in one direction and the other. That looks like a waste. And I always tell them, yes, but you already have that problem. You're just not modeling it. You're ignoring the problem. You assume that one synchronous pipeline can safely transmit that without failure. And ignoring that possibility is irresponsible. And this idea that we can now have two message queues, this is the problem that we need to iterate on. But the problem exists already because it's on two different microservices. And a lot of let's say teams who might be, some junior, a mix of architect, tech lead, junior, engineering manager, they collectively might not be ready with the ramifications of this kind of thinking. Where if I had a monolith before, and I split it up into 100 microservices, now I need to think about, okay, how many calls am I making across the wire where they can independently fail in either direction? I need to have, oh my God, that's a lot of things that I need to now think about. That's why microservices are complicated. Because if you upgrade from a monolith to a service mesh, your architecture and especially the style of your communication also needs to flow. So usually the problem is that, remember, Camila made a very good point about if there's a linear path. Well, sending a request and expecting a response back is always a loop, right? So it's code is executing on my end, then we go over to you, we come back, this is a loop, and then I continue, and you sort of wait again for my request. And then we keep going with this dance about I will call you, you'll immediately return, and then I will continue execution flow when you respond. And these are loops in business flow. And usually what happens is that and then inversion to temporal coupling, if you want teams that are building different microservices to not lose their minds trying to synchronize with everybody, you need to start thinking about how to inverse the loops, how to break the loops apart, how to make parts of the loops repeatable. Try to understand, if I send you this message and you're down, did you receive it or not? Right? So did it go to a message queue? Should I know that or should you know that? Should I send to a message queue? But then how do I know that you will process it? Because if you don't process it, I will want to cancel it if you don't process it within an hour. Right? So there's all these like time-based guarantees that you might want to make between microservices. And it is this conversations, like how do they, because usually what teams do, they model what this feature is, and they model what this feature is, and they ignore the overlap of, okay, but how do they touch? What is the nature of the coupling? Because now we have a time-based coupling that might go bad. We might have a conformity problem. And a very good example that you can follow, a guideline, is from the DDD crew on the GitHub repository. You can check out domain-driven design context mapping. They have like 9 very simple patterns of how the owning side looks like, what is the nature between coupling between services. And I would encourage you to also look into connaissance to understand, okay, am I coupled through timing? If I'm not coupled through timing, am I coupled through execution order? Right, so if I write something to you and read in a separate request, and write something again and read in a separate request, if the order in which they arrive is different from how I sent them, is what I assume to be the last to read, is that going to be consistent? That's a very hard problem. And you don't have this problem if you don't have microservices. Now, but if you went from a monolith to a microservice, you might not know that you have this problem. You might not be aware that you can run into this problem. You might already be having symptoms of this problem, but you're not aware of it. Because this is eventual consistency. So welcome to eventual consistency. It's not that, and the annoying part with the eventual consistency, which is really the symptom, the negative symptom of unhandled, lazily modeled temporal coupling, is that at the time when you get the response, you don't know whether you're consistent or not, because you don't know what guarantees have been made. So you might be tempted to check again in 5 seconds. Because in reality, how you would want to be consistent with data as time flows through different microservices, you'd want information to be pushed to you, not to be pulled. Right? So the you can think of a request response type of coupling to be push-pull, push-pull, push-pull. Right? But you really, in order for this to make sense and not be a loop that cannot be interrupted, you want it to be push-push. And then that other server, you'd want to be able to delay that and say, push, I'm processing, hold on, okay, push. Right, so it goes from one server to the other. Now, I didn't prepare any diagrams here because whenever I show diagrams on the screen, I usually lose you because the example needs to be much more complex to be able to make sense. It makes much more sense if you give me an example of what you might have been working on regarding connaissance and temporal coupling, and we can take a look into that. So you're always welcome to join the discussion to talk about your problem. We don't have to stick with my example. My example we stick with because I always assume that there will be somebody who hears about this for this first time in the audience, and I would like to sort of give an example that is tangible for everybody. But I'm aware that it's sometimes oversimplified. Now we covered the main topics. I would like to prefer keeping today a bit light because we had 2 streams right now this week, and a lot of you were there yesterday. So, so I do appreciate that. I'm just trying to get the articles. I'm just checking what I missed. So one of the things that came out recently in the DORA report, now the Linear B report for 2023, interviewing 2022 companies, is that it is mostly the loosely coupled architectures that we talked about last week, in combination with trunk-based development, that makes everybody's life on your team easier. Because they are able to temporally decouple from each other's workflows. So they can focus on what is my increment of work, and I can deploy independently, even though you assume that when I'm ready, it'll be that final state, I can still deploy independently of while I'm building my way up there. So I control, okay, is this going to make a mess? Is this backward compatible? Is this going to be up when you assume it to be? Is there a message queue? Are the messages on the message queue versioned? Are there different versions of the same message queue? Is the URL versioned? These kind of problems can arise when a team is benevolently using things like branch by abstraction, message queues, messaging inversion, or just alternative kinds of messaging, maybe protobuf, maybe Avro, using a combination of more. You have what is the other one? The RabbitMQ clone, IronQ, I believe. There are all sorts of different queue messaging services that you can configure to give you different guarantees. You might want to have a guarantee that if I call a function on another microservice, that even though it's down, it will be delivered. Or maybe I want a guarantee that if it wasn't delivered, I want a guarantee that it wasn't, not a maybe, right? So there's a lot of maybes in this kind of system. And I don't want to get into the high-speed stuff about locks and the synchronization problems that happen at like CPU level, nanosecond, picosecond level concerns. I'm more interested in the high-level architecture because that sort of more mimics the social structures of the teams. So the Dora report mentioned this idea that loosely coupled systems allow teams to move independently from each other. Because it's logical, right? If you look at it, if I'm building something and it touches 7 microservices, then I don't want to have a meeting with all 7 microservice owners to let them know that I'm deploying something. So they need to be up while I'm deploying, because I will crash if they're down while I'm deploying. Right, so it creates all these kinds of sort of directionality problems of I need to talk to that person and they need to talk to me if they want to deploy while I'm building something. That creates a whole bunch of problems. That's one aspect. The other aspect of loosely coupled architectures is that it is loosely coupled not only by time, but also by different connassences, maybe of meaning. Maybe I'm not coupled to the database flavor. Maybe I'm just coupled to a DTO that arrives from the ORM or from some kind of API layer. This is usually the case with like front-end to back-end communication. You're not actually coupled to the database because you're not sending queries. Although with Next 14, now that's apparently becoming a thing. I'm not sure how I feel about that. So let me know if you're a Next developer and you've sort of started seeing this trend with like PHP and React and the new React templating stuff that's been happening last year in summer this year, when there was this idea of, okay, we're going to have PHP again. We're going back to PHP and templating engines, and we're writing SQL queries with the whole serverless movement and edge function movement. So I wanted to highlight that all of these concerns are architecturally seams. They are connection points, essentially. And you want to be able to refactor a system from one connection point to the other. That's the whole sort of holy grail for what we're aiming at. Is that if I'm on a team and we own 7 microservices, and then I'm coaching this team about architectures, what I'm trying to get them to understand and to read document is where are the boundaries of these connection points. Because we are allowed to test and change and break everything, even change guarantees inside our joints, our skeleton, and not break any guarantees outside of it. In fact, we should not even assume that outside of our system anything exists. Perhaps we should have a zero trust architecture where we should assume that all services will be down at the time when we call them. So they need to have some kind of retry policy or some kind of mechanism to say, okay, before I call you, I will ask you to guarantee that you'll be available to handle this request, and then we do that high frequency, sort of low latency required thing that we want to do. So for example, and this shocks me to this day, is that if you play a lot of Dota 2 especially, or CSGO on Steam servers, now if you're not a gamer, it's not important. If you're a software engineer, you might know that the Steam API, the game services, have for the past 15 years consistently have maintenance for 3 hours on Tuesday mornings. Tuesday mornings in European time, because that's when it's, I think, the afternoon in on the West Coast. Right? So that means that there is a temporal coupling that has existed for the past 15 years, and nobody is organizing tournaments that overlap with a Tuesday in Dota 2 and CSGO. Everybody's avoiding it like the plague, because they know that servers go offline in the middle of the match, and there's going to be weird stuff going on. Because the matches themselves are session-based. So they require close telemetry, low-frequency telemetry. There's payment, there are bets, there's all kinds of stuff, gambling happening while the matches are in play. And nobody really knows how that system behaves when it's offline. With the exception of offline tournaments, which have their own local systems. But those might also suffer from the same problems. Right, so back when these Steam servers were created, somebody said, oh yeah, we'll just take everything offline on Tuesday morning for maintenance, because that'll be easier. Because you will just couple it together and then we'll go offline for 1 hour every week. And that is a type of coupling that the user notices. And of course, that kind of system cannot give strong guarantees on how much uptime they will have, because they are guaranteeing that they will not have 100% uptime specifically on Tuesday mornings. That's very hard if you don't know about this, because it might surprise you. I used to work at an esports company that automated blockchain supported Dota 2 and PUBG tournaments. So you can imagine my excitement as a gamer and as a software engineer working in that ecosystem on something that has asynchronous messaging, map microservices, etc. Like, for me, that was that was my sort of the sweetest dessert that you could give to me for my career. That was a pretty cool time period. So let's see if you have any questions. If not, let's make a recap and let's slowly wrap up the stream, because I am a bit under the weather today. Mr. Focus, I think this helps, right? Yes. So I'm a bit under the weather today, and I still have another call. I would like to rest and spend some time with the kids while we do that. Let's wrap up. If you're a software engineer, if you're an engineering manager, if you're an architect, one of the most interesting problems you'll be solving are those that are dealing with temporal coupling. I can tell you this already. Now, interesting might be a loaded word. They might be complex, they might be annoying, they might be flaky, they might be unpredictable, they might be hard to test. But generally, the hard problems come from managing our understanding of flow of time. Then there's the aspect of Rahul, camera focus out of sync, so not coupled. Yes, I agree. Regarding your team's productivity, being coupled in any way other than collaboration, right? So think about it this way. It's when the right thing is coupled at the right time, that's collaboration, right? So 2 engineers or 3 engineers pairing or ensembling, that's collaboration, because they are coupled at the same time, appropriately dealing with the same problem. Now, what's not useful is what you would call localized sort of on-site work, where 3 people are coupled to sit next to each other in an office, and they are working on 3 separate problems, right? So that is the monolith, that's the big ball of mud example, where I might have 2 microservices, and I might say, oh, I need to merge these 2 because it's always cohesive. The microservices are chatty. When one of them is working on something, they're always talking to that other microservice. They should be merged. Because obviously the chattiness is an indicator that they should be always collaborating. They shouldn't be decoupled. And a monolith, a big ball of mud monolith, is something that is inappropriately coupled because you are coupled all the time, even when you don't need to be. That's sort of the definition of the big ball of mud, is that even though I don't need this part right now, it needs to move and stay in movement while I'm changing this thing. And I might accidentally touch it and move it in some weird way and then mess up deployment. And if the guarantee for that big ball of mud was 1 deploy per day, and now I start deploying every 5 seconds because I'm working on some small problem, that might actually be disrupted for everything else that you're accidentally coupled to. Because you're coupled by locality, the same uptime. Because everything is in the same context, but it is not cohesive. It is not intentionally coupled, it is accidentally coupled. Right? So that is also one of the aspects. And teams can also discover this. So to wrap up, this is essentially today's topic. The third part of our conversation is essentially Conway's law, in effect, where if I sit next to somebody and I chat with them and we're building the same service, so if they're a backend engineer, I'm a front-end engineer, or if we have microservice A and microservice B, and we talk to each other, and then we exchange data with each other in a certain way that is not inverted through some message queue, it's very likely that because we sit next to each other and we chat, that is also how we will implement our services that we own and we're working on. Right? So the seating arrangement heavily implies the temporal coupling and the identity coupling between microservices. That's essential. And to be fair, I cheated a bit. So it's not the seating arrangement. It is the structure of the communication flow in the organization. Right? So because they are sitting next to each other, if they ignore each other, that's no problem. I mean, it's a different kind of problem. But if they're sitting next to each other and they constantly code together, and they're constantly talking to each other about what they're coding, it's very likely they will eventually couple together, either in deployment, or they will go to the lunch at the same time and they will deploy at the same times because of that. And so they might have same assumptions about uptime. So one of the things that, I think incorrectly is termed an inverse Conway maneuver, but it is actually Conway's law. There's no inverse going on. Is if you're a manager, try to figure out how the services are most naturally cohesive. Right? So if you have 3 microservices that are constantly talking to each other and you have performance problems, that's probably one microservice. But it was probably developed by 3 different people, or by one developer in 3 different weeks while they were micromanaged to work on only one thing at a time. And so try to understand how you want your architecture to look like, to then figure out what do the communication, how do the seating arrangements need to look like between your developers, between your team members, so that they will naturally, even if by accident, create that kind of architecture. Right? So this happens a lot with, let's say, I'm working with a company now that's outsourcing front end. What's really important in that kind of scenario is you have a local backend team and a remote front-end team that works. Not only are they not local, as in the same physical space, they're also working asynchronously, which means at different times. So there's temporal coupling there, but also coupling of meaning. It's like we have the backend thing and you consume the backend thing, but you don't tell us what to develop, and our customer consumes your front end, and sort of there's this flow back and forth. And I can guarantee you, in any kind of effort where there's a front end being developed, they need to be chatty, extremely chatty, with whatever middleware exists directly behind the router for the API. Usually there's a huge level of chattiness there, especially if it's like an in-house project, an MVP or something similar. If it's like an open host service like Stripe, they're going to have their API well documented and locked, so that if you say I want it somehow differently, they can just tell you to F off, and no, these are the rules. You can be chatty, but we might rate limit you. Right? But if there's a sort of front and back end thing going on, and there's this chattiness happening. Sometimes architects will then go, yeah, no, because there's a lot of chattiness, we'll use WebSockets. But my recommendation is, if there's a lot of chattiness, try to get the developers in the same room at the same time. That's the better solution. That's being either the manager or the leader, the gardener. Just nurture the environment. To create such a system well, make sure that the backend team and the front-end team are pairing together. So they're developing both ends at the same time and talking to each other. That's the best recipe for the architecture. Right? So the best recipe for the architecture is how you set up the communication flow in your team. It has nothing to do with architecture diagrams. Architecture diagrams are actually going to be a signal that there is already some kind of asynchronous handoff thing going on here. And that might already be in the way of being able to say, okay, because I need to wait for them to respond so long, I will avoid making requests to them, the other team, but I will be extremely chatty with what's local to me. And that, again, is Conway's law, right? Because I might need something, I'll solve it on the front end somehow. I'll put it in local storage so that I then can avoid this long feedback loop, right? So that's what you want to manage as a leader, even as an architect. Like, how should people work together? Encourage pairing. One of the things that I do often in the coaching sessions is I just sit in and I say, if we have too many priorities, maybe we should zoom out a bit and see who needs to pair with whom so that this problem becomes easier to manage, so that the complexity of the features that we're developing becomes easier to manage. And usually a team of 5 or a team of 8 will pair up naturally. It's like, oh, I would like to work on that with them, and then we can help me. Yes, and then, and usually it's 8 people working 8 different things. And if you just encourage them to pair up together, it might create this incentive that because of their chattiness in actually developing it synchronously, about being on a huddle on Slack or just being in a physical same space, that it will have a positive effect on their architecture and make their architecture loosely coupled. So loosely coupled with other things, but chatty in the right way that is appropriate, right? And so that's cohesion. So that's coupling is good and strong where locality is being observed, and coupling is loose when we are actually talking to some other system. But me working on part B and you working on part A, when it's molded together, it's not a safe assumption to make that this is going to be a microservice or that it can be chatty. That's usually a recipe for disaster, where you want every developer to be independent and you enforce every developer to own a microservice or a fleet of microservices. And then you ignore this fact that some of them are extremely chatty with each other and have a whole bunch of performance problems, or God forbid, routing problems with Kubernetes, or then, you have this sort of, we want to be like Google, but we don't really have any DevOps people on board. We don't really understand DevOps. So that's to be wary of. The best architecture happens because the best architecture happens accidentally when the communications hierarchy in your team is well nurtured. So usually you don't want it to be a pyramid going up. You want it to be like a hub. You want your communication flow in the team. If the team is working on like 7 different priorities and there's 10 people, you want that to look like, if you ever looked at it, like the public transportation system in Tokyo, where you don't have a downtown and you don't have an obvious exit, but there are like districts, and every district is connected with their neighbor. And if you want high volume immediate access, it's hub to hub. And if you want chatty access, it's local streets connecting one segment to the other, right? So it's neighboring districts to neighboring districts. And then they sort of dilute through that the same way as veins in a leaf do or veins in your skin do. So there's a natural diffusion of where does the high volume of API calls go naturally. So it's already set up in such a way that you can establish communication flows that will then mimic the natural architectural flows of a complex, let's say, complex multi-component effort. Anjana has a response, and we can wrap up with this. I sometimes mock a response for front-end to use so we can deploy parallelly. That helps when feature expectation is known. And it's a very good example. And, I would encourage developers to even We do this a lot with event modeling. Anjana, I don't know, do you know event modeling? Because what Adam Dimitruk often says is that if you express your system in this happens and then this happens, and then you know what your events are, and you can separate your projections from your events from your commands, then you might be able to say, well, we all agree on what the final projection should be for the UI. So let's mock that first. But let's not mock that in the test sense, in that there is a temporary, like temporally auto-destructive sort of mock that is just it's non-functional. It just makes the test happy, but actually worked often, but not always. Okay. But I would encourage you to actually think about creating a permanent version of this mock. So create a like version 0 or version 1 or version 0.1 that is a test version that always responds with static content, and deploy that to production with a test user that can be reliably tested in that environment. And then rather than having mocks, just maintain that version of the system within your code base. And then you can make it private only or developer only or staging only at some point. Right? So don't throw your mocks away, but actually promote them, make them real living things in your system where you say, oh, this is the endpoint that when I call it, I will always get a cohesive but static response. Cohesive meaning that it might have connections with some other entities, and it'll always be this, right? That's what we generally in testing lingo call fixtures, but it's very artificial if they are fixtures for mocks. You can just have the fixture in a production level state, production ready, production quality state, and then not have to write code to mock that. This is particularly useful when when you have microservices and you have team A, team B. But I would encourage you, if you're integrating with them, I would encourage you to have a fake that just manages the structure, the contract, but not the server itself. That's really hard. If you're mocking a server, Anjana, I would recommend that you check out contract testing. Because if you're mocking a server, you're probably mocking an interface of a server. It's like if I call this method, it will return this. Right? So you're mocking identity and value. Right? So I mock it. Mock response will incrementally be replaced by true implementations. I like that, but I would encourage here, don't replace them. Just add the option for it to be mocked or real. Because the mocked one will always be useful for testing purposes. But when it comes to microservices, I have encountered this problem a lot, especially when I first worked in a company that did microservices. In that they have, what I did is I created a lot of them, but I didn't create rules of, what is the neighborhood? Like which services are more chatty? Because what happened is that once we got to a point where we had 80 microservices, for example, and Anjana, I don't know if this applies to you, the scale, the granularity, the chattiness here, if it applies. But what happened is that once we had like 80 microservices, we started seeing that like 5 of these belong together and 10 of these sort of belong together. Like there is a sort of locality forming, like there's a neighborhood of families of microservices. And usually what we would want to do is we would want to spin up the entire family to run a really high quality test between them, but not outside of it. So what really helped me sort of architecturally, and then especially like coaching the other teams, is to say, whenever I build a server, like just like you did, I will also create a mock server for you, the other person, the other team, so that you can get a mock server from me that you can use in your tests when you're testing your system with my mock server. Because I will guarantee that my mock server still follows the same contract as my real server. But I'm developing the mock, not you. And that is a much better way of testing, where if I integrate with you, I don't write the mock server. If the team also works in the same company, I ask you to create the mock server because you will create a much better one. And then I just ask you for those mock servers to always be backward compatible. Because if I ask you for your mock servers to be backward compatible so that I can continue testing with my tests, just by having asked you that team is now also positively incentivized to also not only make the mock servers backward compatible, but also the API. Because if I ask you to have the mock servers backward compatible because of my tests, your tests are also relying on the mock server, so your real API will also be backward compatible just by virtue of how we have set up a communication contract between the teams that seemingly had nothing to do with production servers, but because this communication happened, we sort of inverted the temporal element of whose responsibility is it to create the mock. Because we inverted that, it also created an implicit contract between these two teams, but these two microservices, that we would always be backward compatible with each other, and we would supply mocks to each other when we need to spin up like in a isolated, zero internet private network, like a Bitbucket pipeline, like a GitHub Actions pipeline, isolated from the internet, spin up, run the tests, crash it, delete it, and then move on. So I would encourage you always, when you have an architectural problem where there's a temporal symptom of over chattiness, don't try to look for mechanical solutions. Just look at the social solutions first, the socio-technical ones first. Try to figure out if the teams are too isolated, try to get them to talk to each other, to pair with each other. Try to get them to ensemble programming. It's like, how would the author of the service create a mock for the context that I'm testing? Think about it that way. Can I ask the author of the service to create a mock for me rather than me trying to reverse engineer it? A lot of mistakes happen in this reverse engineering step. And that's also what happens when we do this on a much higher level, when we have architectures and then somebody sees an architecture diagram and they try to reverse engineer the timeline or the roadmap or sort of estimate the project based on the complexity of the architecture diagram. That's always dangerous. So try to get the communication flow aligned. So socio-technical for good architecture, and time coupling and guarantees and what you can give regarding management and processes, right? So nurture rather than manage/micromanage. Final check for comments. If I missed anything, let's see. Okay, I'm up to date. Very good. So thank you all for your questions. This is a lighter, more tactical topic. So I'm reserving the more leadership-oriented, strategy-oriented conversations with Adrian, because we seem to have a nice cadence now going with these bi-weekly streams. So next week there will be another stream with Adrian, probably with some DevOps management practices. And these solo streams are more chill between just you and me to discuss perhaps more coaching and tactical-oriented and architectural matters, like we did today. And I'll keep mixing them up and keep changing the formula to make it exciting for you. I'm aware that the holidays are coming, so this will become probably an escape from all the Christmas activities. So I might be focusing a little bit more on entertainment, a little bit more entertainment for the holiday season, for all of you, rather than just education and sharing. So if you would like to hear me talk about a particular topic, or if you would like me to invite a particular guest that you might be interested in sort of quizzing or talking to, do let me know. I'm always open to feedback. You can send me a message on LinkedIn, or just this event if you're watching on LinkedIn, or if you shoot me a DM or a reply on Substack for the newsletter, where you can always stay up to date with what's happening with the stream. I'll be very happy. I really value your feedback, and I will try as much as possible. It's one person giving a good suggestion for the stream will be acted upon. Balazs, one of our regulars, asked at some point to open the discussion with me and Adrian about trunk-based development, and I think we made 3 episodes on that, and those were one of our best episodes. We also enjoyed them a lot, right? So it's, don't think that your voice is a minority. You give us a good suggestion, I'll host a solo stream on it. Adrian might host. We might host a joint stream on it. The sky's the limit. Oh, Raul has a question. Let's go, Raul. Last question for today. If you follow an event carried state transfer, Raul is a Martin Fowler fan. That's typical Martin Fowler speech. Event carried is state transfer. We kind of avoid many of the issues with other patterns because our microservice is almost independent. Correct. So I will mention again, Eve's Go 11 is a sort of educator, evangelist for event sourcing. And he has a very nifty blog on 9 patterns that handle essentially most line of order business processes, right? So anything that you would want to realistically have as a modern web SaaS company can be solved using those 9 patterns. So those 9 patterns are like the Lego bricks with which you then create a complex architecture, a complicated architecture. And it's the difference, let's say, with a team that is comfortable with event carried state transfer, right? So event carried state transfer, that is that idea that an object calling another object does not happen message-wise synchronously directly, but the message call is event carried. But you may lose the ability to send a response, right? So in tactical speech, mechanically speaking, all functions are asynchronous void functions. They don't return anything, right? So the return path is actually a push path somewhere else. That's CQRS essentially, and that's why CQRS is actually very, very much pushed as an architectural pattern by architects, because if you adopt this thinking of event carried state transfer, you avoid a lot of these issues. Now, if you do CQRS and you try to still avoid event carried state transfer because somebody told you eventual consistency is bad and you should avoid it, then if you still do CQRS or microservices and you're not serious about event carried state transfer and you want to live in this synchronous box that is perfectly locked and synchronized all the time, then you'll end up in a lot of trouble. And a lot of teams that I observe have exactly those microservices problems, where they have microservices, but they are not doing event carried state transfer. They are doing exactly the same kind of synchronous, constantly temporally coupled across the mesh synchronous calls through REST APIs. God forbid that they're even SSL terminating inside the private network and are carrying over session tokens from each little microservice, and each little microservice knows how to decode the session. I've seen that a lot. That's just a mess, because it's synchronously coupling as if it was still inside the monolith. And that's not solving the problem. That's just making the same problem more complex. And that's the real big ball of mud, a distributed monolith. That's the real big ball of mud. What you want is a modular one. And you get modularity by temporal decoupling, by things like event carried state transfer. Thank you, Raul, for mentioning event carried state transfer. It escaped me that this might be an important key point to raise. When will you say this pattern will not be appropriate to use? So I think, event carried state transfer, I think, will always be appropriate, but it's sort of the developer that pays the price for doing everything like this by default. Because there might be, most of the frameworks that exist are not event carried. So it's not really a business problem. It's just so much that as far as developer ergonomics and developer experience is concerned, a lot of the frameworks that you are working with do not support event carried state transfer by default. So this is the age-old question of, are we doing actor patterns with event sourcing, or are we doing CRUD with MVC? Are we doing Redux with stores? or are we doing hooks and sort of global state, right? So that's this problem. That is the temporal decoupling of, is the method call event carried or not? So when it is not appropriate, I would say it's not appropriate when you are mechanically inexperienced and more importantly unenthusiastic about building a system like this, right? So if you don't care about event carried state transfer, about learning it, and somebody's forcing you to do it that way, then it would be inappropriate. Because a lot of high performance systems, Dave Farley talks a lot about the LMAX system. The LMAX system is one of the sort of lowest latency sort of stockbroker, I think it's a market maker system that handles on extremely low latencies at extremely high volume and extremely high performance, and it is event carried. It is, it's using very complex systems that are doing CQRS on a level that is optimizing CPU cache usage on the sort of events that it carries. But that is extremely advanced. It is possible, but it also creates a very robust system. Greg Young is actually writing 2 books, I think, on event sourcing that does touch on this, where it is safe to build all systems like this, but it has to be preceded with some passion, some enthusiasm, inspiration from the developer to not resist this idea. Because the moment you start resisting it and you sort of want to go back to your sort of CRUD, here's a transaction script, here's a page, and I will just click buttons and then that will go into the database. And I want to have full sudo write access. I want to be able to just go in and delete everything and recreate it. That kind of system, albeit simple, most complex problems where companies are willing to invest a lot of money into technologies aren't successful because of such problems. So if you are building another WordPress, my recommendation would be use WordPress. But if you're not using WordPress and it's going to be a complex project because you're doing something uniquely different, I would encourage you to check at least to event model the system. If you have synchronous elements like microservices which are locally local, which are maintain synchronous communication between components that have high locality, I would encourage you to find the really important seams that require event carried state transfer over the wire because you're building microservices. So that would be my sort of more convoluted and wider answer on this topic. It takes a lot of work to use this pattern, but as with everything, it has its good sides. Yes, it is, exactly. But it's a lot of work to use this pattern because most frameworks are not optimized for this kind of usage. With the exception of, what is it? It's an Elixir. It's an Elixir framework. Elixir. What is it called? Akka, right? Is it Akka? Scala? Did I mix up the... Yeah, Java and Scala. Yeah, so Akka. So for example, Akka is a very good framework. It does this by default. And it's very good because it makes non-event-based state transfer extremely difficult. Right? So it is a framework that has doubled down on this approach. And it says, if you think like this, it's really easy. And if you resist it, we will make your life really difficult. Because once you resist the pattern, you will create this whole temporality problem of, is this synchronous? If this was asynchronous and this is synchronous, what guarantees do these systems have between each other? And that's a very complicated problem. There's a very complicated open-ended problem that might not have a clear answer. So that would be sort of my recommendation. But most frameworks, the people I see use like Symfony, Node.js, even with things like T3 Stack, Next.js. Next.js is probably getting really close, but I'm always worried when React developers and such, you expose them to this sort of functional paradigm where we're sort of supposed to declaratively program with event-based state transfer, and I see them every time. There's a little feature with hooks or a little feature with, if I can just cheat and change the state of the button directly, I will do so. So there's something very tempting about cheating an event-based system. I don't know where that's coming from. I don't know whether that is just a difficult paradigm to grok, or whether that's just the state of the frameworks, where the frameworks are easier to develop if they're not doing it that way. But it is definitely a framework problem. It's possible that there's no money in this. Life in itself is event-based. So if you create a web application that is naturally event-based through event-based state transfer, it is possible that there is a much lesser percentage of your code base that requires a framework. And maybe that's just not marketable for framework creators, right? Because usually we think about people who are coding not as C# developers, they are .NET developers. We don't talk about, I'm a JavaScript developer. No, you're a Node.js developer, or you're a full stack developer, or you're a React developer, right? So people, there's this tribalism going on with which framework do we use. And most frameworks are synchronous. They're not by default doing this actor-based event carry state transfer, with the exception of the whole event modeling movement, event sourcing, Akka, and Axon. And but don't mix it up with Kafka. Kafka is a different paradigm. Kafka is a more message queue system that can also give you some guarantees on durability, but not a lot. It's think of Kafka like RabbitMQ. Don't assume that somebody who's using Kafka is doing event sourcing. So that would be my take on this. I really like where this conversation went towards the end. So thank you a lot. Thank you a lot, Camilla, for chiming in. Adrian, I saw you in chat for a moment. And Anjana, thank you. Raul, thank you all for coming. Thank you for your time. I will now wrap this up. If you want to make some friends, if you want to connect with each other, I would encourage you to stay in chat, sort of chat a bit. Check who else is still here. Maybe say hello, I am still here, so that people can reach out to you if you want, connect, network with each other. And I'll be joining my book club call in about 20 minutes because we're reading Accelerate. We are doing speed reading today about the book Accelerate and DevOps, and I'm really excited about that. And I need to take a short break before I jump onto that one. So, elevator music, awesome topic. I had a lot of fun. Today was a bit more low energy from my end because I am a bit under the weather. Thank you so much. And see you next time. Ciao.